Well, as we work with continuing algebra 2, we're going to talk about these linear functions. And linear functions as a group, you should have been introduced to in about 8th grade. We often think of them too as linear equations, and the function concept came later. But that function where we put something in and we get something out of a function. So talking about first, the linear function is going to be a function that can be written in the form of f of x equals mx plus b, which may be very familiar, where m is going to be and b are going to be real numbers, and it's going to consist of a set of ordered pairs all lying on the same line. And that may be very similar to the, right here, the y-intercept, not the y-intercept, sorry, the slope-intercept form, which we looked at y equals mx plus b, and we could identify the m in this case was considered my slope, and we did just talk about that when we talk about rate of change, the slope, the rise over run, and then the b value, which is going to be my y-intercept. That is going to be the y-intercept, and that is going to be where your function crosses over that this point right here, where it crosses over what would have been the y-axis or your f of x axis, and that would be my b value. And in an ordered pair, it would be, remember, 0, 1, 2, -1. The x value would be 0, and then it would be whatever that value of b is, would be the ordered pair of my y-intercept. Okay. And let's see what else. Then you have the point slope form, which is point slope and standard standard form, two forms of an equation of a line that we're going to work with again. There's basically these three forms, and I would say from my experience, the slope-intercept form is the first form you work with, point slope is the second form, and standard form is the third form, and they all bring their own benefits to the function and to graphing. Each one of them is easier based on some characteristics, but they all equal the same line, or can be the same line. They can just be written in three different forms. Okay, so we're going to determine if a function is linear, and then we're going to represent a linear relationship numerically, algebraically, and graphically. Okay, let me see. We can talk about each one of these as we go forward. Now, my slope-intercept form, this is the one you've probably been working with the longest, is the slope is a linear equation given in this form. Y equals mx plus b, and we said before that m is going to be your slope and b is going to be your y-intercept. And in order to graph this, what we're going to do is we can take, and we're going to graph it on a coordinate plane. Some basics for your coordinate plane is you want to make sure that you have your axes labeled. So I have my y, my x, and you want to make sure that you have some form of measurement identified on your graph, because everything, we have to go back and repeat it. So in this case, I would have 1, 2, 3, and of course my origin is 0, and then I'd have -1, -2, -3. And I'm just using some examples here, and then I would have -1, -2, -3, and then 1, 2, 3. So I've identified the measurements on my axes. This is a good starting point right here. This would be, hey, this is a great graph that I've drawn to get started. What would not be a good graph would be that. It would be that. Right now it doesn't look good, and then this would not be good either. If I had 1 and then I had 2, 4, maybe not so good. Or if I had 1, 3, 7, because the space in between here is 1 unit, the space in between here is 2 units. The space in between here is 4 units. And all of my units, all of my spacing needs to be consistent. So looking here, this represents 1 unit, 1 unit, 1 unit. So I'm being consistent with my identification on my graph. So this is definitely no good. So now as I go to graph, what can I graph on this slope-intercept form? So if I pick an equation, okay, so if I go to graph this, I have a function example here. Graph f of x equals 2x minus 1. Well, I'm dealing with a function, not a line, so what I want to do is make sure that I'm labeling my axes correctly. So it's going to be x and f of x, right? Because f of x is going to be my output, x is going to be my input. And it is going to be in slope-intercept form, and there's two. The most basic way here is I know that, remember we said that this is going to be my y-intercept. So -1 is where my function is going to cross over my y-axis right here. And then the slope, m, is going to be, the coefficient there is 2. So my slope is going to be 2. My b is going to be -1. So slope is also going to be equal to 2 over 1. And that is going to be my rise over my run. The change in y over the change in x. So I can graph that by starting at my y-intercept. I can go up 2 over 1 and make a dot. I can go up 2 and over 1, make a dot. I can also go down 2 and back 1. And if you'll notice, it looks like I'm forming a straight line because my slope is a constant value. The rise over run is the same everywhere along that line. And this would be considered f of x equals 2x minus 1. So I've identified that function if I were to graph it. I could also have created a table. A little bit more time consuming, right? So I have my function, 2x minus 1. I have the x values, I have the y values, and then I'm going to get out of that sorry, it's not y, right? We're dealing with a function, f of x, and I'm going to get out of it an ordered pair, x f of x. So I'm going to have this ordered pair that I'm going to get out. And I can plug in any values that I want for this x value, because remember, that's my independent variable. I can pick any number that I want. And if I wanted to pick, when x is 0, f of x, so I would have f of 0 is going to be equal to 2 times 0 minus 1, which when I do that, remember this is identifying, I put a 0 in, my x is going in, so I replace everything with x. 2 times 0 is going to be 0, so I have 0 minus 1, so my f of x value is going to be minus 1, so this ordered pair is going to be 0 minus 1. And if I were to look at that and say, okay, where does this get graphed? Coming over here, looks like 0 minus 1. So there would have been my ordered pair. And I can do that with any of these. Let's say if I plug in 2, f of 2, when I plug x as 2, I'd have 2 times 2 minus 1. And that is going to be, when I plug x in for 2, my output is going to be 2 times 2 is 4. 4 minus 1 is going to give me a 3. So my ordered pair is going to be 2, 3. Come over here and look, and sure enough, 2 going up 2, 3, and that is going to be my ordered pair. There we go. So you can see that that line is forming whether I graphed it from the knowledge or I graph it from a table. So there's my slope-intercept form and how to graph there. As I go forward with point slope, now point slope again is the same equation, or I'm sorry, it's a different equation, but it's the same line. You know, you're making a line, a linear function, a linear graph. So have to remember when looking at this point slope form that this y1 and x1, that is some ordered pair, right? They've given you an ordered pair. So they've given you some x and y value, and you're going to substitute that in. And then, of course, m is still going to be your slope. So if I look at an example, so looking at this example now, if I have an equation of a line, and it is written in point slope form. Hopefully you can see that. I have y minus some value equals m times the parentheses x minus some value. And what I want to do is say, hey, well, what is my point? My ordered pair. My point is going to be what? And then my slope is going to be what? And I'm hoping that, well, according to our function, we have y minus. That's my formula, y minus. So what is this number here? That is going to be, my y value is going to be 6, right there. And then my x value, I have x minus some x value, and that is going to be right here, 2. So the ordered pair, or the point that I have, is 2, 6. That's my x and y, right? And now my slope. My slope is still going to be the value of m, which is right here. And that is going to be right here, which is going to be, my slope is going to be 2. So that's the information that I could pull from that. And if I were to graph that, well, I could take and graph it. So I have y and x, and I want to start at this point right here, 2, 6. And I'm going to go by intervals of 2 just because it's convenient. I'm going to be getting large numbers. So that'd be 2, 4, 6, and -2, and -2, 8. So if I start off at that point, 2, 6, I'm looking at 2, 6. That's where I'm going to start. And then my slope is equal to 2 over 1. 2 over 1, rise over run. So I can start here and I can go up 2 over 1. I can go up 2 over 1. I can go down 2, back 1, down 2, back 1. And then I have this line forming right there. I just started at a point and a slope versus starting at my y-intercept. But this is going to be y equals, gosh, what is it, y equals? Well, if I want to take and I want to convert this equation into y equals, I'm going to solve for y. So we'll say we have y minus 6 equals 2 times x minus 2, and I want to, remember, isolate my y in order to get y equals. So let's do my order of operations. I don't have any, I have parentheses, but there's nothing I can do inside there right now. I have no exponents, but I have multiplication. So first of all, I need to do my multiplication. So I'm going to distribute that 2 to both things inside, and I'm going to have 2x minus 4. Okay, now I'm going to isolate the y right here. So I'm going to add 6 to both sides, and that creates a 0 pair. So I'm going to end up with y equals 2x plus 2, because 6 minus 4 is 2. And there you go, there's my equation. So I end up with y equals 2x plus 2. And understanding that y equals 2x plus 2 and y minus 6 equals 2 times x minus 2 are the same line, they're just written in different form. Back here and say, let's use that example, and I'm going to put it in standard form. This thing right here. And when we move on to that third form, the standard form of a line is ax plus by equals c. What do we know here? We want to know that my a value, a is going to be, I better not put equals, a is going to be positive in standard form. And then it's not 0, and then the greatest common factor is going to be 1, so basically your a is always going to be, your a is going to be a positive number, and that we'll just stick with that for now. So let's see here. Let's pull up an example, and we are going to. So we have, as an example, I had y is equal to 2x plus 2. And in order to get it in standard form, you'll notice that my x and its coefficient and my y and its coefficient are going to be on the left side. So it looks like we already have our y there, but we need to move this one over to the other side. We're going to do that by using the inverse operations. So I will go ahead and subtract 2x from both sides to get it over there. And that will give me negative 2x plus y is equal to 2. Okay, well, I do have x and my y on the same side. I do have my constant value on the left, but remember, a is going to be positive. So in order to make that term positive, because it's a negative 2 now, I'm going to multiply it by a negative. So if I multiply it by negative, I have to multiply everything, right, by a negative. If I multiply one side by a negative, I have to multiply the other side by a negative. That's using the properties of equality. So that ends up becoming 2x minus y equals negative 2. Now, I will say again, by looking at this, remember I multiplied everything by negative 1, so negative 2 times negative 1 gives me a positive 2. Negative 1, because you got to remember there is a 1 there as a coefficient. 1 times negative 1 is going to give me a negative 1y, equals 2 times negative 1 is a negative 2. So now this is now written in standard form. My variables and coefficients are on the left, my constant is on the right, and my a value is positive. So there you go. I use that same one just to show how they are the same. So this is the same line as this, it's just written in a different form. So using that standard form. And I will show one more example of point slope, and it's remembering that when it comes to point slope, you have that rule where your point slope formula, not rule, your formula is y minus y1 equals m times x minus x1. And the formula is calling for these are minuses. Those are subtraction signs. So if I need to identify my point slope form, if I have an example of y plus 3 equals 2 times x minus 1, well, I'm in point slope form, and I want to know what is my ordered pair. What is my point? Well, my x value and my y value. Well, looking at my x value, it is x minus 1. I have x minus and then the value, so this is going to be a 1. That is going to be a 1. However, I do not have y minus. It's not y minus and a number, it's y plus a number. So if I were to rewrite that, that would look, the same thing would be y minus a negative 3 equals 2 times x minus 1. Because negative and a negative become a positive. So I have y minus, so that means the y value is negative 3. That's my point. And my slope, of course, is still going to be that value right there, which is 2. So just showing you that you got to make sure that you're following the formula, just like when we talk about standard form, that a value, that first value, the coefficient of x has to be positive. When you're looking at these, your formula is calling for that to be a negative. So just keep that in mind when you're looking and practicing these skills.